Welcome, and thank you for joining us today. I'm glad you're here at the first virtual SQL Pass Summit. Hopefully, this is the only virtual SQL Pass Summit. I know virtual training and virtual conferences are going to be a thing in the future, but the in-person events to me mean much more. The networking is fantastic. The learning and meeting new people and exposing different things instead of being isolated into our rooms and just looking at our computer screens. In fact, I feel I usually get more from networking and talking to other people at the in-person conferences than I do actually getting from these sessions I attend. The sessions are always fantastic, and I learn lots, and almost always something I can use in my day-to-day world every time I go to a session. However, the networking, the long-term contacts, those kind of things, which make me be who I am, are where I want to be at. So I can't wait to be back in person, to see everybody, and to get to visit with all my friends again. So again, hopefully this is the last virtual SQL Pass Summit, or at least the only one. The rest of them should be more like the 24 hours of Pass, which are still fantastic learning sessions, but you don't get to network as much. So what are we going to talk about today? We're going to talk about next generation intelligent infrastructure. What this means is infrastructure is getting smarter and smarter and smarter, and how is this going to impact the DBA? And we're going to talk about different technologies that exist today and things that are going to be in the future. We're also going to talk about the concepts, what's behind all this, and what this really means, and help you understand what's going on with this. So first, make sure you explore everything Pass has to offer. And there is a ton of things to do Pass. Obviously, if you look on here, we've got the networking and training we talked about, of course, in your local groups. I've presented at multiple user local groups, and this is a fantastic way to get to know the people in your own community kind of stuff. And then, of course, SQL Saturdays. We all love SQL Saturdays. I usually do 4 to 6 of them. I only managed to do 3 this year because of 2 virtual, 1 in person before we all had to be locked down, which is a fantastic system. And of course, the Pass marathons, my virtual groups, I do involve in a lot of virtual groups, not involved. I have presented at multiple different virtual groups, so make sure you're paying attention to those, plus attend those sessions. And lastly, of course, Pass does need volunteers. Pass as an organization will not be able to exist without the volunteers, so make sure you get involved and help out. Do what you can. Really implore you to be involved in the organization. Next, session evaluations. Again, there are prizes this time for doing your session evaluations. There's always prizes for session evaluations, but make sure you put them in because we want you to win prizes. But the big thing is, as a speaker, I like to learn and get feedback, figuring out where I can improve, how I can change, how I can improve different things, just whatever you want to. When I first started presenting, I was very, very rough. I've gotten better, I believe, with practice, but also I've gotten better in many areas because I've learned from the evaluation of people. So they give me the reports, I listen to them and figure them all out. I also go out and seek other people who've actually watched my sessions a lot of time and ask them point blank about things. So again, fill out your session evaluations. I'll remind you at the end of the session to hopefully you can get around to fill it out. And hopefully, if I fill it out for this session, you are one of the lucky prize winners. So please, again, fill out all your evaluations. So what are we going to talk about today? Well, we're going to talk about a lot of different things, which is why intelligent infrastructure and AIOps is important. So we're going to figure out what's critical about this. First, then we're going to go talk about what is intelligent infrastructure and AIOps, and then what it's going to be able to do for you. And along the way, we're going to show some demos of some things which are on the cutting edge of intelligent infrastructure, but we're not quite there yet. There's a long way to go. We've got some parts of intelligent infrastructure in place today, but there's more on the horizon in affecting mostly, in the compute, networking, and storage facilities. But imagine having your infrastructure just work and not have to worry about it. Think about your infrastructure like you think about your phone. You don't spend time thinking, will my iPhone be working properly? Will my Android phone, Samsung Galaxy, whatever version you have, be working properly? You tend to just works, and you want to be able to forget about how the stuff works in the background. I want, the infrastructure world should be very similar to this. So first about me. So my name is Shawn Meyers. I'm a field CTO over at Tentry. I became an accidental DBA in 1995. I started, being full-time DBA in 2003. I started playing with SQL Server 6.5. I've actually seen 4, but I was an intern at that job, and I got to log in and do a few things, but I really wasn't managing anything. more of doing backup stuff. My next thing in there is kind of a cheeky statement. It's saying, hey, working with databases since 1982. And you look at me and go, hey, there's no way this guy was born, been working with databases in 82. Well, my dad was a developer. And when that happens, he made me learn things when I was a kid. So instead of having an Atari 2600 like all my friends did when we were kids, and they were playing video games all day long, I had an Osborne 1. So if I wanted to play games, I had to learn things. He also forced me to learn databases. He forced my brother to learn spreadsheets. So I had to go build a database for my mom's Hummel collection, which I don't know if you know what Hummels are, but those little small figurines they used to buy kind of stuff, and kind of like precious moments, but Hummels were German, I believe. And she had a large collection of those. And see, I had to track where she purchased it from, what price, when, and this kind of stuff, and what number in the series. And we had to go back and forth and figure these things out. And then, of course, she sold a few of these and traded some, so I had to have different kind of tables of when she acquired it, when she got rid of it, was there a return on it. So my dad made me make multiple tables and relationships, so I learned a lot about relationship data back in 82. So I'm getting close to be able to say I've got 40 years of experience with databases. I also have a lot of initials after my name, but I really don't talk about them. I don't keep a lot of them current. I've earned certifications over the years and then expired ones, and I'm working on new ones just so I can learn new technologies. It's always important to maintain being current. All right. I've been a speaker at SQL Pass Summit. This is my third or fourth presentation here. I've spoken at SQL Bits. I've spoken at the past 6 VMworlds, multiple SQL Saturdays, VMugs, virtual user groups, local groups, all kinds of different things. So I like to present. I like to be involved with the organizations, and I like to help others. In fact, I've challenged multiple people to become speakers and presenters, and a couple of them are actually presenting at Pass this year as well. So it's always good to see people I have pushed and challenged to become places and have now moved in and become part of the community as well. So Rob Gerard was supposed to present with me, but due to multiple different issues, Rob couldn't. But he'll be on for the Q&A process. So Rob also is a person I work with at Tentry. He's the principal technical marketing engineer. He is a geek. We sit around and talk geeky stuff when we're together, especially when we go to conferences together. We'd be up at 3 o'clock in the morning somewhere, drinking and talking geeky things. We wouldn't talk about other stuff, but we'd talk about different ways to make protocols work better, or storage constructs and how to improve things, or even what indexing rules should be, kind of stuff. Rob has many initials as well, and most of his are more current than mine. And of course, he's a speaker as well at VMworld, SQL Bits, and other events as well too. Next thing, slide. I like to talk about this one just because it's always fun to have the different perspectives, because each one of us has, do multiple different roles. And with that, everybody who looks at us from different realms sees us differently. And this helps us understand, of course, or this doesn't help us, it's more funny and cheeky, but again, helps you see that other people see you differently. Because what I think I do versus what I really do versus what my boss thinks I do, and of course what my mom thinks I do. Because most moms I know think, hey, yeah, my son works on computers, or my daughter works on computers. They really don't know exactly what a database is or database administration is, kind of stuff. And of course, users. Users think we just do fancy Excel sheets. And no, it's not. So next 2 slides, we're going to talk about storage issues and talk about that from a DBA perspective and then the infrastructure perspective. So in my previous lives, I used to be a SQL Server consultant. And what I did that was basically I'd have to come in and help translate between the infrastructure folks and the database folks. And that's what the things we're talking about here is there's a lot of differences between the languages that infrastructure teams use and the language that database users use or DBAs use. And we're going to help understand the gaps of that, but also to the point of we want to make it so we don't have to think about this, so the DBAs don't have to learn about infrastructure. Infrastructure just sort of works, and which is the goal of intelligent infrastructure. Infrastructure that just works, and the DBAs no longer have to think about it. So the first thing I'd like to talk about is lack of time and skills. And it's not necessarily DBAs don't have skills. DBAs have fantastic skills. The problem is DBAs don't have skills in infrastructure. And to be honest with you, DBAs shouldn't need to have skills in infrastructure. But in today's reality, many times the DBA has to learn a lot more about infrastructure than they really want to. I mean, Glenn Berry has done some fantastic blogs and information over the years about different infrastructure things, and then understands the servers and memory and compute and processes. He's made basically a good living at this because he's helping other DBAs understand what the technologies from infrastructure mean to them and how it's going to impact their day-to-day lives. So again, DBAs have been learning things they don't want to learn. So what it means is it's hard to fix storage issues. If you've ever had to deal with storage issues and troubleshoot them, they're always very difficult. And you have a persistent one, it stays there. You're going on, what's going on with this? You look at everything you can understand in your realm of the deep database side, and you know something's wrong. My latencies from the DMV virtual IO file stats is way too high. We have to go figure things out. The problem is you talk to the storage team, nothing happens, and then eventually we all have to get to, I call the meeting. What the meeting is, of course, is we get the DBA, the storage admin, the Windows admin, the network admin, the virtualization admin, sometimes one or two application admins, and some other people thrown into it. We all sit in the same room and go, hey, look, here's our problem. We define the problem. We all agree, yep, that is our problem. We should solve it. So we all sit there and go, we type on our laptops, we do our things, and we go, yep, not me. It's not my problem. It's somewhere else on the stack. It's someone else's problem. And then we do some finger pointing processes. So as I mentioned in my previous life as a consultant, I'd come in a lot of times and act as a moderator, an arbitrator, or the person to help just create test scenarios to help us figure out and isolate where this problem is at. Because obviously there's a problem, and sometimes their problem exists in multiple areas. Sometimes their problem exists in the database itself due to bad database design. Sometimes it's a virtualization setting wrong. Sometimes it's storage. Sometimes the network path for the storage, because Fiber Channel at the end of the day is still just a network. So sometimes the network admin runs it, sometimes the storage admin does, but end of the day, we have a problem somewhere in the stack and we have to get through it. Very difficult, and nobody has time for these kind of meetings because no one has extra time these days. Then I talk about database slowdowns. What I mean by that is there's a lot of things DBAs we have to do on a regular basis that can cause production slowdowns, i.e., DBCC check DB. When I run DBCC check DB, it's going to impact performance, so I always have to figure out when I can run that. I also have to refresh test and dev systems. I have to copy data in and out. I have to do all kinds of different things. And then, of course, I have to do maintenance. Not maintenance, but data protection tasks, which are things like snapshots or my backup processes. All these things, again, affect performance, and I have to schedule around when peak times are at. Now, imagine if we can isolate that and not have any slowdowns from those. Next, waiting on other staff. What does this mean? We're talking about waiting for others to do things. Common tasks, for example, i.e., I have a database. Every weekend we do an ETL into the system. The ETL basically copies new data into my system, just fine. However, and we average, say, 25 gig every weekend. No big deal. Well, due to catalog changes, whatever, some large change in the organization process for a sales thing, the ETL this weekend, instead of being 25 gig, turned out to be 500 gig. Wow. We had a massive, large, increase in this. Okay, we're fine. We still actually have a lot of headroom in our systems because we planned properly. We kept 30 to 50% headroom on all our drives. But now we're very tight. We may run out by this weekend because we know another 25 gig or another 100 gig is probably coming this weekend because of the data changes. Hey, I have to plan for that. I don't have enough room. So I opened a ticket. I need more storage. So I don't know where everything is all at, so I just open a storage ticket. So first it goes to the storage admin. Storage admin looks into the disk pool inside the storage array, says, hey, I can go expand this. So expands the storage pool, and then goes ahead and looks at the LUN. The LUN, yep, LUN is fine. It goes and expands the LUN. Takes the ticket, forwards it on to the virtualization admin. The virtualization admin looks at the ticket, goes, everything's fine, looks at sees the LUN, the LUN's been expanded, now it knows I can expand my data store. Expands the data store, and then goes into the virtual machine, edits the virtual machine, finds the right vdisk, and expands that vdisk. And then forwards that ticket off to the Windows admin. The Windows admin now takes this ticket and looks at everything, logs into Storage Manager, and basically expands the drive. Or disk manager, depends upon which version you want to use of Windows, and expands the drive. Now the DBA has access to the space, and phew, crisis is averted. However, if you've ever worked in a large or mid-sized organization, this is a 2 to 3 week process because each ticket has like a 48-hour queue process, and then it has to go through multiple steps, kind of stuff. And so all of a sudden now I realize I'm going to run out of space by this weekend, and it's Wednesday, and all of a sudden I realize I can't wait for the normal process. I have to go run an escalation. That means is now I'm going to be calling my VP or filling out more forms and doing extra steps. And now I'm going to interrupt everybody's workflow to go get this drive expansion done very, very quickly. Of course, this is kind of annoying because now I've interrupted a bunch of people, and it's a problem that we all can agree is a simple task to do to grow a drive in a system. But I had to wait on other staff to do this. Next thing I like to talk about is inadequate visibility. Basically, it's very difficult to correlate a lot of times a database to where it's at. Back in that meeting we talked about, understanding where the database is to which disks it actually resides on. It's very difficult sometimes, and a lot of times there's multiple spreadsheets involved to figure these things out. Plus, we don't have good details on the performance characteristics for each database and how much each one was running. And then lastly, unpredictable per database performance. What I mean by that is databases run, and however, if I happen to have 20 databases on a SQL Server, one person who runs really bad query, i.e. some cross join, some new junior level business analyst just writes a query because they don't know what they're doing and understands the impact of the query plan and stuff. Just a horrible thing, does gobs and gobs of table scans with cross joins and joins back to itself. Again, bad written query. And now it slows down and uses all the I/O from that system. The problem is all other databases on that same SQL Server now suffer from slow I/O. So other applications are being impacted. And of course, nowadays in a consolidated virtualized world where we have the same problem, now I have multiple SQL servers on that same data store, all being impacted by one bad query. So it's very hard to provide predictable performance for your systems, because one person on one of 60 or 70 or 80 kind of databases can do one thing that can slow down all the rest. There's no way to provide any kind of QoS or quality of service processes per database. So let's talk about the same things from the storage admin or infrastructure admin's perspective. We've kind of already talked about visibility, but it's difficult to troubleshoot. And of course, they have to get in that meeting. They don't know. You say, hey, this database XYZ is having performance problems. That means nothing to them. Someone has to tell them, look up that database XYZ resides on this server and on these vDisks or drives, for example. And then they can look at that to go figure out which data store it is, to go figure out which LUN it is, to go figure out what the disk pool is. So it takes them 3-4 pieces of information and probably cross-references of things to get to anywhere to go troubleshoot anything. And that takes a lot of time, which is why a lot of times they say, hey, guess what? The storage pool looks fine. Everything is looking great. We don't have any storage problems. They didn't actually drill into it. They just looked at the big picture of storage and said, hey, storage is okay. Next thing we talk about is performance-related inefficiency. So one thing I see a lot of is storage administrators or infrastructure administrators tend to over-provision for SQL servers because they don't like troubleshooting these things as much as the DBAs don't like troubleshooting things. So the easiest way is to let's just over-commit things, and I don't have to worry about as much. Let's take a database that only needs 50 IOPS and put it on a storage array that can generate 60,000 IOPS. Why? Because I don't want to have to deal with that meeting, processes, and which means inadequate. We were now over provisioning, which means we're not allocating our assets for the organizations wisely. We're just giving things away just so I don't have to deal with troubleshooting processes because they're difficult. Which leads to the next thing of long-term planning issues. So storage administrators have to understand not just the capacity, because the DBAs do a great job of tracking capacity and the growth of their databases, but they don't do a great job of understanding what the performance changes of the database. Meaning it was cranking out on average, for example, 1,500 IOPS last year, but this year it's at 3,000 IOPS. It's double the amount of IOPS needed or performance it needs to run on a day-to-day basis. And of course, obviously, during maintenance windows, when you're doing like backups and CheckDB, things are going to use a lot more I/O. But again, from a performance capacity perspective, it's very difficult to understand that. And there's no easy way. The DBAs don't provide good reports back to the storage admins about, hey, when we're going to need more performance capacity off the system. We just ask for the fastest possible system all the time. And then now we talk about data protection and DevOps. There's a lot of really cool ways of doing snapshots and cloning processes in the storage layer to make some things much faster. The problem is this is all at a LUN level. So if I have 80 databases on one data store, one LUN or one volume, I now clone things at a LUN level, and now I've made a copy of all 80 databases. There's no granularity in that. I have to do everything at a big picture process. And if I decide to design my environment so I can have a lot smaller, that means I have a lot more things to manage. Imagine having to manage each individual LUN for each database would be next to impossible for most large organizations. And then again, we mentioned quality of service and the inability to provide per database performance and to guarantee performance and isolation for each individual database. That's fantastic, but right now there is no way for a QoS to happen at a per database level. So what we're going to do now is basically do a quick demo. We're going to actually refresh a non-prod database from production. And what we're going to talk about here, this is actually going to be part of the whole data protection concepts, where we can now use storage-based snapshots to protect our databases. And then when things go bump in the night, we also can recover from that snapshot, very, very rapidly. So we're going to do two different things. One is refresh a non-prod, and then we're going to do recovery in production. All right. The bad news, of course, is my monitor for this is on a different screen. So as I switch things back and forth, I'm going to be not looking into the camera while I'm doing this demo. So first thing, I've got a couple servers here. I've got a past prod server and a past dev server. Let's go expand these databases. All right, databases wise. So we're going to play with the AdventureWorks DW data warehouse database. And this one is basically, it's the same thing. I've blown this database up. I've added some more tables, and I've added some extra scripts into it to just inflate things, some cross joins and other stuff, just to add a lot more data into here. As you can see, this database is a 322 gigabyte database with a nearly 8 gig log file, so 330 gig overall total space. We're going to make a copy of this and refresh a copy into our dev server. As you see, on the past dev server, for example, database-wise, I actually have an AdventureWorks DW data warehouse database here already, but I don't have a. Why can't I click on it? There it goes. Must have a network issue real quick. I don't have a past clone database version of it. So what we're going to take an AdventureWorks DW database up here, make a clone of it, and put it down into a different server. And show how fast I can clone from a production server to my dev server. To do that, I have to go into the storage console processes, but of course this can be done via scripts, from PowerShell or REST or whatever you want to go use. But this is basically I work with Tentry, so I'm going to use a Tentry storage system to show you what intelligent infrastructure from a Tentry perspective uses, and how we do some of these things. But under our storage pane, basically I go to databases. I'm going to select the right SQL Server, which of course we talked about past prod SQL Server. Expand this out so I can go see my AdventureWorks DW data warehouse database. That's a mouthful to say. AdventureWorks DW, day 2017 database. So right click on this, actions, and I can choose clone. I can take snapshot, I can do lots of different things for data protection, but do clone. As I mentioned, we're going to change the name of this to pass. If I can type properly, clone. I use the clone name just so I know it's a clone. That way I can easily track what it was, where it came from, and it's my lab, and so that way I know I can delete things quickly. So snapshot-wise, we're going to take a new storage snapshot of just this database, and we're going to put it onto which SQL Server. In this case, I'm going to put it onto a different SQL Server. The good news is here, like I said, I'm trying to filter out which ones it is. I can just type in the name of the server I want, in this case dev, and it's going to filter out all my dev servers for me. And now I can find my past dev SQL Server quickly. And then I got to figure out what directory I want to put the data file into. In this case, my dev servers can't see my production server, so I'm going to go ahead and put it in the dev server share. And click clone button. I'm going to count to 3. So 1, 2, that's faster than I wanted it to be, but normally it takes 3 to 5 seconds. Now I go here to databases, right click, and choose refresh. And now you see I've got a past clone database. Right click, choose properties, and what do I have here? I have a beautiful looking database that's 322 gigabytes in size. I could be doing inserts to this while this is happening, and the clone will happen, and basically obviously wherever that transaction is at, it's going to clone only on the completed transaction. So anything in flight wouldn't be cloned, wouldn't be there. So any transaction that's open would basically be rolled back on the process. That's why this runs so much faster here, is because there was nothing going on in that database when I did it. But I can make a full copy of that database that quickly. That's pretty fantastic stuff. All right, so let's close it down. So that's what some other things we can use that for. So besides just making my dev and non-prod environments, keep them up to date so I can clone, I can refresh as often as I want to. I can have scripts and give it to the developers, and the developers can refresh their database when they need to. And every single developer could have their own copy now. And I can do it very fast, because every time I do a clone of that, there's actually no space used from the system, because it only tracks the changes of it. So as I make a clone, I make edits to it, and then only the Delta file will show up from the changes of that. So if I actually go into here and go look at my database systems, from past dev server, I can go in and go find that past clone. Right now it shows undefined, shows I'm using 6 meg in space. So if I did a bunch of inserts and changes to systems, then you'd see that space amount of space being used would change because of how much I'm using. But at start, there's hardly any space. I've got a 322 gigabyte database, a clone of it using only 6 megabytes of space, because all it is checking the blocks that are different from them. Fantastic way. Again, now think about that from your developer's perspective. Now, every single developer should be able to have their own sandbox that they can control, refresh on demand when they want to, as often as they want to. These are the concepts we want to talk about for intelligent infrastructure. Things of just being simple to do, easy to do, and allows to make things more productive, allow you to drive more innovation instead of having to spend more time on tasks where we have all those massive, really cool, awesome backup restore scripts, backup copy restore scripts, some sort of log shipping that has delayed apply processes, or snapping an availability group secondary and then bringing that online for the developers to use. I mean, whatever thing you've done to refresh your non-prod environment, this is obviously much simpler and can be scripted to do whatever you want with as fast as you want to do it with. You'll think about that from your DevOps perspective if you're running DevOps environment of how you'll easy integrating things. So again, part of the whole data protection process. Let's talk about this next script here. I call this one bad update because we're going to do a bad update. Actually, I'm going to make sure I actually have some data protection on this server first. So we're playing with past prod, and we're going to use the AdventureWorks database this time. Let's go expand this out so I can see which database is which, because you can see I have multiple AdventureWorks databases. All right. So AdventureWorks databases, and do I have any snapshots on this? And yes, I have one from the 27th is daily. Let's just go take a new one, just so I know I can have a good valid copy. All right, we're gonna leave this one past demo. So now I have a new snapshot called past demo of this database, just to make sure everything is good. All right, so we're gonna look at the AdventureWorks database, and we're gonna select from person. My last name is Meyers, and of course there's a Meyerhoff in the AdventureWorks database by default. Well, actually, I want to update it to Meyers because I like my last name and I think I should be in the AdventureWorks database. So I go run the query to update, person. I'm going to set the last name to Meyers where the last name is Meyerhoff. Simple update statement. But I'm being lazy, not really paying attention, and I don't highlight everything. And oops, I just ran a query and I updated all 20,000 rows in my database. So let's see, what did I really do? Uh-oh. I don't have, I look at this and every one of my customers are in the person database now has the last name of Meyers. I have got a problem here. I don't like this. How do I there's no undo button. There's no are you sure thing in databases. We all know this. This is one of those things that happens in real life, and it's unfortunately it happens. So, simple way to do this. So again, back into control plane. I'm going to go to that latest snapshot I took for past demo since I already have it open. We're going to clone this back into the same server. We're going to give it AdventureWorks clone, same server, and again, I got to specify where I want it on my network share. And boom, click clone, and 3 to 5 seconds later, it's going to be there. Uh-oh. I already have, I had a database already existing with that name. Let's go clean that up real quick. Yes, I did have one. So we're just going to go delete this because I've done this before and I did my test demo, but I didn't clean everything up. So we're going to delete the clone because all my scripts actually have the name in it, and I don't want to do a bunch of typing in my demo. Yes, demo failure. And I probably go re-record this, but I may not. Well, it depends on how much time I have. All right. So we're just going to do the clone process from here. AdventureWorks clone, new snapshot. No, we're going to take the past demo snapshot. So it's going to be the past version. Again, same SQL Server. And we're going to go ahead and use, again, the same DB path. Now we're going to clone, and it's going to be complete just fine. Sorry about that. Show you, we all make mistakes. So now I have the clone database. I just deleted it. I re-put it here, so refresh. Yep, it's back. All right. So select from person. I see here, hey, look, L has the right last name. So I've got my simple update statement that's going to pull, from, the AdventureWorks clone database and basically update the AdventureWorks database. Pretty simple script. And execute. All updated. So now go back to the AdventureWorks database. We're going to look at the person table again and see that everybody now has the right last name. So now we're going to go make sure that the Meyerhoff is actually put back here properly. And yep, that person's still there. So if I want to go update it still, I can go do that update statement now if I wanted to, or I don't have to. But now, of course, I did my cleanup scripts. So just showing you some of the cool concepts of what we can do with data protection, and with that, the speed of process. The cool thing is about those snapshots are zero stun. They have no impact to your database system. So no matter what you're doing from a production standpoint, when I'm doing those refreshes or fixing things from those processes, I don't have any impact to production speeds. Production does not slow down, does not pause, it does not waffle, it does not do anything. So I could be doing that snapshot every hour on the hour, and you would never be able to figure out from looking at SQL Server when that is occurring. So that's pretty fantastic stuff. And it doesn't matter if you're running transactions in flight. Again, it makes a snapshot process, and only completed transactions will be done. Anything that's in flight that's not completed, when you basically, I do that clone, when I bring it back into SQL Server, it goes through the startup process and the redo, just like when you reboot a SQL Server, it goes back and finds things that weren't completed and removes them out of the data system. So pretty simple stuff. All right, that's enough of this demo for now. Let's go ahead and go back to the PowerPoint. All right, so now talking about intelligent database storage. So we're going to use the Wayback Machine here for a bit and talk about what happened in the past. What we mean by that is, let's talk about how storage and infrastructure was working before we had virtualization and or consolidation tasks. A long time ago, we used to have storage compute systems, and we tend to have one database per SQL Server and one SQL Server per basically LUN. So shared storage arrays, they're a microcosm of our data center. There's an aggregated pool of CPU, memory, network, and storage, assembled for the purpose of providing persistent storage to other services inside my data center. And historically, in support of servers, the primary mode of consumption of these storage arrays has been the LUN. And configuring a LUN depended upon some understanding of the capabilities of my pool of storage resources and the requirements needed by the application layer. So we had my servers, and we had to understand how much storage each one of these servers needed. And so we would carve up a data storage for my database based upon what my requirements really were. We didn't share anything, and so there's a one-to-one relationship between my storage array, my database, and my server, and I knew what was going on. So properly configuring storage array was an exercise in translating the requirements of one to the capabilities of the other. So the server had requirements, SQL Server had requirements, and the storage array basically had capabilities. We would just translate them and map them up. And then for the next SQL Server, we do the same thing. How do we do a SQL Server? Create more databases, create more storage, create more different LUNs, and do the design processes. So each application was tuned with the right amount of storage it needed to have. And so there's a one-to-one relationship for this. So then we can measure telemetry at the LUN level, and it gave us great insight into the behavior of the application. And this still represents a relationship between the application activity and storage. This would be an excellent foundation to enable intelligent infrastructure, because when we have one-to-one relationships, we know exactly what each application needs in terms of storage performance. However, we had virtualization and consolidation, and what that impacted the different things. So the translation, from to virtualization mostly, and then of course consolidation, where we added more and more SQL Server, or more and more servers to each system, or more and more databases to each SQL Server as well. But this is not designed, so today, one-to-one relationships do not exist in our data center. We changed the SQL servers out, and we put in virtualization hosts in most cases these days. And then, of course, we stacked multiple SQL servers on top of each one of these. And then, of course, in each one of these SQL servers, we add multiple databases. This is one-to-one relationship changed. As more databases were put onto one server and virtualization, LUNs were now data stores and no longer mounted one-to-one, but one-to-many. And adding additional complexity to the connectivity between the SQL servers and the storage array. Further complicating the matters is the LUN is no longer represented at the granular unit of management. It was no longer tuned based upon the needs of the application or the database. Now, in this model, a data center measurement and LUN level telemetry does not give us reasonable insight into the behavior with the application that runs within them. So we don't know where things are at. So which database is running where on all this kind of fun stuff. Plus, we add the fact that in a SQL Server, virtual machines can move between virtualization host and the storage arrays, and completely unaware of this. And so the storage array can move data files between data stores. This is why we find things which worked yesterday but don't work today, and no changes were made to the environment. So from a DBA perspective, this is one of the most frustrating things. Everything is running fine. The infrastructure team, or even just some of the cool things in the virtualization layer, just automatically tune some things around. And now I have much slower storage all of a sudden, and things do not work anymore. I have problems, and yet I made no changes. And it's very hard to go prove this, and then we have to have the meeting before someone tries to figure all that out. And constantly untangling these relationships can consume up to 95% of the operational overhead associated with managing storage systems in these environments. We talked earlier about those spreadsheets and how complicated they were. Well, guess what? Well, now these things can move around in hopscotch all over the place whenever, and some of it's in an automated fashion. It is very difficult to know what is where and how that in fact impacts performance. And there's no understanding whatsoever from the storage array process, from the infrastructure back up to the application, and how much resources is needed, how much is required, and these kind of things. As you can see, the databases can be in different locations and move back and forth, and where they're at, we don't know. It can move back and forth. So the infrastructure teams are basically been operating blindly, and they have less visibility than they had before they did virtualization, before we had one-to-one, because we had to carve up things for each application. Now we stack it all in one giant pool and hope the pool just takes care of itself. And this is where the implementation of monitoring, management, and automation tools, is meant to relieve some of these overheads. And so third parties basically add lots of different things. And of course, these issues are compounded in larger environments, resulting in a majority of operation cycles being wasted on a number of administration actions, leaving little time for innovation or other value actions. So now we have a bunch of setup issues, sizing, performance, manageability, bottlenecks, and of course, innovation gets pushed down to the last thing, and we have less and less time to go spend on innovation. In this paradigm of siloed staff, we get this finger pointing and wasted cycles. It's not conducive to meeting the needs of the organization. We spend time talking about different people trying to get things accomplished, or going why, what changed, how things worked, and so on and so forth. Which, of course, sometimes it comes into a full circle to figure out where the problem really resides. And these are never conducive. They're never beneficial in most cases, because what happens is we now have hurt the relationship with some other person, so now they're less likely to be proactive for us. And all the finger pointing that goes around, all these things are typically very bad for your environment. Now remember, everything is about the application, not the database server, the network, storage, or any other infrastructure piece. The applications and the user's experience is where the focus should be. And infrastructure should support the application, not trying to figure out how to make the application fit into the infrastructure. And this is one of the things we tend to lose over the years. We all focus on database performance. We talk about storage performance. We talk about this. End of the day, none of that matters. It's the experience our customers/users are having with the tools they need to do their jobs, or complete the transactions for our sales. That is where we need to focus on. And so that's what we got to stop thinking of, hey, look, my database can do X, Y, Z. Don't care. Does it meet the needs of my customers? Yes or no? That kind of stuff. And so that's where we need to focus at, and stop thinking about database performance, storage performance, infrastructure performance. Start thinking about the application as the center framework for everything, and making sure we're enabling the application to run properly, not for maintaining my SQL servers. Which brings us to intelligent infrastructure. So with our focus on solving issues and created by repurposing LUNs to support consolidated SQL servers, and compounded by the breadth and scale and consolidation of virtualization of SQL servers in the modern enterprise. So intelligent infrastructure is built around a core of monitoring, management, and automation capabilities, requiring the support to dynamic churn from large-scale enterprise environments. The difference is the software being built into the storage system. The difference of the software being built into the storage and operating system integrates many of the operations found in third-party tools and designed to resolve the issues described earlier. Let's focus on the primary areas that involve in all this. So now I've got all those things wrapped up into my storage appliance. I no longer have those three sections here where I had my automation tools, my monitoring tools, processes. They're all part of my storage appliance concept. And this is what we're talking about when we talk about intelligent infrastructure. We now roll in simple things into there, so it's now part of the stack. So end of the day, these storage appliances with intelligent infrastructure, they should be very easy to deploy. You should be able to go from box to production in under an hour. You shouldn't need to constantly consult with professional services. There should not be complex setup routines that we have to tune lots and lots of different variables. We shouldn't have to have massive spreadsheets and workbooks to figure out how we're going to configure things. We should be able, again, take it out of the box, plug it in, assign an IP address, and be ready to go. So intelligent infrastructure, when you have a simple process like this, we remove the whole setup process. It's gone now. And then the database, it should be the unit of management. Each individual database should be managed and controlled separately from each other. This way, our applications, allowing for database granularity and data protections, performance metrics, refreshing non-production copies of databases, and offloading of reporting to other management things. So we should, again, think about this from a database level, supporting of the application. So the SQL Server is here and allows us to manage each individual database down in the storage array. So we should never have to think about as a whole with drives and LUNs and volumes. We should think about it at a per database unit of measurement. And if we track things this way, we can simplify the automation tasks. The intelligent infrastructure integrates directly with the C2 or SQL servers and pulls information to gain contextual awareness from the databases and database files. So we know this database resides where, blah, 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 and understanding how the relationship between the database files, and where it resides in storage. And then secondly, intelligent infrastructure uses integration with the SQL Server and Windows Network to gain contextual awareness of the database files that live in the file system, but also allows us to understand when the I/O requests leave the SQL Server and when they receive at the storage array, and understand how long that time took to get there because of the different layers things have to go through to get to these places. This allows intelligent infrastructure to take storage management actions like snapshots, replication, and synchronizations at the database level. Snapshots, replication, and synchronization. This is per database, not at the LUN level. So this actually makes our manageability of our systems much easier, and we resolve management. Intelligent infrastructure also monitors data file usage, capturing great statistics, including read-write percentages, AIOps, cache hit ratios, block size, and all the different kinds of data storage telemetry you would ever want, but having this per SQL Server database and per SQL Server database file. This allows the array to tune resources based upon the I/O patterns being utilized, and information that allows the VM store to take advantage of database level actions per database, tuning the operations for each database individually from others at the same time as other SQL servers. We call this QoS, or quality of service. Auto-tuning storage will allow for predictable performance, things to work the same way, and not to have performance changes to databases when nothing else has changed in the configuration or the entire infrastructure stack, which of course means we have performance resolved. And database level actions per database level, tuning of operations for each database individually from others on the same or other SQL servers. And having per database metrics at this storage layer can result in autonomous actions and the ability to expose insights to where latency resides in the ecosystem. So we can see, is it coming from the SQL servers themselves? Is it coming from our network process or somewhere in the storage process? And having the information and insight where this is all at, or even the QoS process we talked about causing some of these slowdowns. This gives us a good idea of removing those bottlenecks. And then lastly, of course, we're going to talk about all the results of these data calculations, where we have autonomous actions and the ability to expose insights to where latency lies in the ecosystems. These behaviors and actions can have been taken by intelligent infrastructure at the database level of performance, and capacity telemetry are recorded and shared. What this means is all these behaviors and actions are now stored up in a system where we can monitor, look at them, analyze them, put them into a structure, and figure out things. And with this, we can do analysis, which provides us with great sizing information. So now I know how much resources each database is using on a minute by minute basis over the days, over weeks, over months, over years, and we can go trend this over a 3-year period even, and understand what the growth rate is, and then use those trend lines to figure out what the future holds to help us do our sizing process. Then, of course, we can run through simulations and figure out, hey, if I have to double or triple my processes, meaning think about Black Friday testing. All of a sudden, now I have to figure out, okay, we're going to go from 100 customers per minute to 1,000. Will our systems be able to handle that? And can I figure out the impact to my storage based upon metrics that we have? And understand if we're tripling and quadrupling the load, do we actually have enough headroom on our storage systems to handle all these workloads? And we can have sizing calculations or simulation calculations to figure this all out. With this, that means we're now driving innovation. We can look at the application level and the storage appliance and figure things out. And driving the innovation helps us move things forward. So administration still exists. We still have some administration tasks, but innovation has now become a larger part of our process. So let's visualize what this means in a big picture scale. We all have many of our databases shown in silos. So let's talk about, so here's our storage ecosystem, and here's all of our storage systems. And we've got production databases, reporting databases, QA databases, and of course, dev-test databases. And all these things are fantastic, and we think about them in a silos process. At least in our charts and everything we use for tracking, we think about them this way. The problem in reality is these databases more look like this. Everything's mixed together. And it's very hard to troubleshoot what each one of these databases is doing from a performance perspective. And so this is why it's so difficult to troubleshoot the performance of just this one database on this system, because everything is muxed together, and we can't separate. Storage systems today cannot separate these all out. And all the users of the applications receive a predictable performance, even though all the storage is mixed together. So it means basically with the QoS process, each database can now provide each individual user predictable performance, even though everything is mixed together. And that's what we're talking about with the concept of intelligent infrastructure. So intelligence, it's a noun. The ability to acquire and apply knowledge and skills. Key facets here: acquire and apply. So acquire the data and then apply that, what you know from that data to make your life better. So now, why is intelligent infrastructure and AIOps important? So we talked about intelligent infrastructure and understanding what we're talking about, the concept-wise. There's a lot of things inside of that. But let's go talk about why this is so important for the future. So if we look at any kind of chart, we can learn about infrastructure. There is more and more infrastructure at just about any organization. Even places who are moving a lot of things to the cloud still have more things on-prem than they ever had before. There are more servers, there are more things to manage. And of course, with all this infrastructure, our budgets and the number of staff we have is pretty much flat. Meaning we have more things to do, but we have less time to do each individual task. So we've been using a lot of things called rules-based automation, or orchestrations, things to automatically do things. And how we do this is figuring out, calculations of different methodologies, and we have to have a human calculate these things. Unfortunately, those rules still have to be developed and written by people. And the people don't always have enough time, by the way. So to keep up with the pace of infrastructure deployments in the next decade, the market must turn to artificial intelligence and intelligent-driven infrastructure to help cover this expanding gap. Hence this whole area here. So we have to let the systems take care of themselves. Now, I know we're thinking, of a Terminator and but Terminator basically, and the machines taking things over. But yes, this is the concept from this. But no. So what is a simple definition of intelligent infrastructure? Do more with less. What this means is deploy more copies of your database in less time. Solve more of your performance problems in less time. Deploy more copies of the database with much less space. More testing iterations with less duplication of effort. More applications with less support staff. More innovation with less money. And innovation is probably the biggest key here. Or you can make up your own version here, but if your boss watched this, she may already have. So let's go talk about troubleshooting and how this can make intelligent infrastructure, because now everything being managed at a per database level allows us to have better insights into troubleshooting for performance problems. All right. we're going to go back over to the management pane here and just look at some things. The cool thing about this is now I have all my databases in one location. I can quickly sort through and figure out what's going on with them and what the amount of throughput, IOPS, and different X's of each database is and which ones are causing problems. And then, of course, I can look at latency and quickly spot which one is being slow. My lab is undersized, and also I'm using, hand-me-down systems, so I have a lot of latency issues because this here, for example, is actually a spinning disk system, so it's not an all-flash array. I can also hover over the array here, over this for latency, and see I've got some information. This is the network. This is from the time it left the SQL Server to the time it got to the storage array. This is the contention inside of the storage array, and this is the flash. So this is basically it comes into the storage processor, and this is actually the flash cache, which is basically what takes this, and then it writes off to the disks. So basically, I've overloaded this system, with processes. So you can see the numbers of here reflect this. But I can quickly spot, hey, which database is my troublemaker right now. But what happens if I need to know about 2 or 3 hours ago? Well, a couple different things. From here, I can click on the main screen and drill into IOPS. Let's go ahead and add a couple more charts, my throughput and my latency. And I can go look at this and see what's going on. My throughput chart didn't load properly. Let's try this again. I should drop throughput. We've got latency. I have this latency spike right here, and I want to know what's causing that. I can just click on this, and it produces and shows me which items or databases were impacted by this latency. In other words, you can see this, my production data, AdventureWorks Data Warehouse 2017 clone had this amount of latency in it. So this one is actually my trigger point. So I can quickly spot, and it has the most latency. Everything else here looks fine. So in seconds, I figured out which database is my slow performer, and I can troubleshoot things down. So now I can go look at this database. We're going to bring this one up. All managed object. Come on. All right. At this point in time. And then I can look at this database, drill down to it, and let's go to metrics as well. So I can go see all the different metrics for this database and point out I've got multiple hours. I can go up to a full month in here, and I can go put multiple metrics into here. So I can actually go look at my throughput, my latency. I can get my I/O percentages, a flash I/O space, all kinds of different things if I have replication processes involved as well. So I can just go look, see what's going on in this database and see, hey, at this time frame, I had a massive spike, in my throughput, in my IOPS, and also, but my latency spike was way back here. So I can now understand that, hey, it's not amount of throughput that's causing my latency spike, something else was. But we now know this here is all network-based, as it shows here. It's network latency and this spike, which basically means it's from the time it left the SQL Server to the time it got here. So something was impacting it before it got to the storage array. Versus when I have my high read processes here, my latencies are all in a good, in a good amount kind of stuff in sub 1 millisecond. And this is, again, per database, I can go look at each individual one really quickly and go figure it out. But now here I can see there was a small increase in throughput, but a massive spike in latency. But the latency came at the, from the network side. So it is somewhere my network was being slowed, not from, so now I need to know it goes back up a step outside of here. Quickly troubleshoot, quickly identify where your problems are at. This is what the fantastic thing about intelligent infrastructure. Everything being managed per database allows us to think about this. So now the applications are going to be impacted by the performance of the database, but I can quickly troubleshoot what I need to know because I have a lot more data, a lot more telemetry about what's going on with systems, and it's easy to go track and understand. All right. I can go on for a long, long time about troubleshooting and actually solve problems from this very, very quickly, but you saw just the depth, the ability to do different things in here is just fantastic. So let's just go back to the PowerPoint and back into intelligent infrastructure and more about AIOps. So we're talking about intelligent infrastructure and AIOps. So again, we got to collect and align log data. There's a lot of log data out there, but we got to pick it all up and analyze it. And then once we have it collected, we have to analyze and detect patterns. And this is where machine learning, and there are many great sessions at Past Summit this year about machine learning and AI. And this is what we're talking about, using those technologies to make the infrastructure much better. Because once we've detected the patterns, we now can go into predictive modeling. This is where the modeling sections happen to determine what should be our things are, which we have our, hey, this is the occurrence, this is our solution for that. So once we have the solution, we can then automate that solution. So the goal is basically take all this information, run it down the funnel so that I have people taking care of the roles. And then, of course, managing the infrastructure. But instead of using human operations, let's just have the systems work automatically. So we can use AI and machine learning directly to optimize the infrastructure components and operations. So a side note, the scope for intelligent infrastructure is narrower than AIOps. While the benefit is more focused, it's still required for the engineering as very special appliances to take advantage of this level of intelligence. But when we remove the people section here, we didn't actually, this does not mean your job will go away or anybody in infrastructure's job will go away. This just means that we're going to remove the mundane, tedious management day-to-day task, or we call the operational burden of systems, off their shoulders and allow them to drive innovation and use new technologies to help the organization be more efficient, do more different things. So we've seen this before. Let's talk about what this means exactly. So operational burden versus innovation. So if you talk to anybody who works, and even DBAs, infrastructure folks, and talking about this, they'll say, yeah, they spend more of their time on operational burden, managing different things, managing security, managing, growth things, just day-to-day monitoring of things. But innovation is their secondary task. They want to do more innovation, but they have so many things to keep the lights on that they don't get around to spend much time in innovation. Let's use an analogy to explain what this actually means. So first of all, we happen to have we've all summer vacation going on a family trip somewhere. And the old days, back when the old Rambler existed, we actually had the map on the Rambler and Dad was the driver. So a lot of operational burden, and very little innovation processes. So we fast forward a few years and we had the map to figure out how we're going to get there. Then all of a sudden we had external software. We had a GPS device that helped us understand where we're going and how to get there. And so it made looking at the map much easier. We didn't have to worry about it. It told us when to turn kind of things. And then we added external software into the system. So we had some machine learning. So we had Waze, which told you there's a speed trap up ahead. But most likely it's more of the accident/road construction. And there's now a better route to get there. And it would change your route in real time for you to save you some time. And then, as we're in today, we actually have what we call hardware with rules-based assistance. Think about this as lane collision detection sensors in your cars today, having the auto braking process if you're closing the gap too quickly, kind of stuff. The things that the amount of burden on the driver is less, and the computer or the car is doing more and more for you. So the car is doing more of the steps, so it parks itself. So you have less burden and less things for you to go do as the driver. So again, the operational burden of a vehicle is getting less. And of course, in the next phase, when we get to self-driving cars, we're going to still be a part of it because we still need the transportation, but the operational burden is going to be much, much lower, and then the vehicle will do most of the heavy lifting for us. I know this is scary, and I actually tell people, my wife and I have discussed this. I said by the time I am 75, self-driving cars will be mandatory, no longer just something we think are cool. They're going to be here, and they're going to be here sooner than you think. Now, same concept this is the same thing with intelligent infrastructure, having it do the process for us. So let's walk through that. So today, hardware only, we have a lot of burden of IT. So all these hardware, someone has to go manage all of it, and it's a lot of labor-intensive processes. So we have some external software things. We have some proactive collision detection things. Tell us what's going wrong. We have some alerting processes, but it lowers the operational burden. We still have to do most of the tasks manually. So we have external software with AIOps processes. It lowers it and makes a lot of recommendations for us to still go do, but we still have to go do it. So we have things tell us what to go do. And then we get in the hardware with rules and the hardware with machine learning. This is basically when we start changing out the pieces of infrastructure for the next generation things. It actually has the intelligent processes built in, which allows the hardware to self-tune, self-heal, self-correct, self-whatever, and it automatically makes the adjustments we need to improve overall performance without us having to do a lot of different tasks. So intelligent infrastructure, which is basically AIOps with external machine learning and rules-based automation. So, and then of course here is we go with machine learning inside. So the machines will learn based upon usage patterns on what needs to be done to help make things better. This is going to impact the network, your compute, your servers, and of course your storage layer. Storage is probably going to have the biggest impact for it. So it does, once we get the intelligent infrastructure, the operational burden processes will now move and slowly decrease, and we'll have more and more time for innovation. There are so many more things we can do as organizations we want to go redo. So again, intelligent infrastructure helps unlock this innovation. So we all know what this is. It's a turn-by-turn navigation appliance powered by a GPS. It collects data. It does pattern analysis, predictive modeling, and of course prescribes a route, but still it's optimized for human being. So the human still has to push the pedals and turn the steering wheel. So this over here is basically the diagram showing the sensor array for a Tesla autonomous vehicle. So you can see is multiple layers of fields coming out, and there's many, many different sensors. This is just a picture of it kind of stuff. It still collects data. In fact, we're collecting the same data, but collected by the GPS, plus much, much more. We're still doing pattern analysis. We're still doing predictive modeling, except it is now autonomous execution of route what's going on. So it's going to move the car without human intervention. I.e., when I had the first cars came out, how you drove them really was the same 70 years later, or even today for most vehicles out there on the road, unless you get one of the new autonomous driving cars. So let's talk about what this means. So a database is unleashed. So we have traditional storage, got a LUN, multiple virtual machines on each one of them. So we can take out here and manage at the virtual machine level, and we can go see great things. The problem, of course, is each SQL Server virtual machine has multiple databases inside of it. So imagine all these being SQL servers, all these being databases, and all of a sudden I've got 60 or 70 databases in here off of one LUN. So one bad query, as I mentioned before, can impact performance for all other applications attached to the same system. Now imagine, if I run this at the database level, everything now is going to be individually monitored per database. So now I can operate everything at a per database level. No more impacts or noisy neighbor issues. No more concepts of this. I can be more efficient on all my data protection policies. So in the artificial intelligence for IT ops right now space, there are a lot of participants. I mean, you can see Big Panda, Plonk, VMware, just the gobs of different things doing all these different tasks. And some only focus on one or two of these tasks in here. And some work with some ones, different ones, and back and forth. I mean, it's just lots of different lines, and there's a lot of different facets for it. Is this really artificial, and is it really intelligent? No, not yet. So right now, AIOps is complicated, but it's going to get easier coming forward quickly. So now, as we talked about the cloning process, remember, refreshing your non-prod environment. Do it in seconds. Do it per database, on demand, on a schedule, scriptable, one copy or many copies. You offloading maintenance. We talked about how doing CheckDB slows down your production database. Imagine if I can do CheckDB on those same storage blocks, so it's the exact same CheckDB, but doing it from a different server. So I can do CheckDB when I need to without having to impact production. Index stat and maintenance still need to be run in production, but now I can seed AGs, I can replicate off the AGs, all kinds of other processes. Again, simple definition, do more with less. All right, it's now for the time for the Q&A, but before I get to that, and the recording, I want to make sure, encourage you to fill out your evaluations. I do want the feedback. And Rob Gerard is going to join us for our Q&A process. And thank you for your time. I hope you learned something from this, and I enjoyed presenting it to you. Thank you.